All right, guys. Algebra 1's finally here. Making sure. Yep, okay. So, Algebra 1. We're on Lesson 17, Equations Involving Factored Expressions. And there it goes. I was about to say, come on, help me out here. All right, so classwork number 1. Solve each equation for x, okay? X minus 10 equals 0, and that's pretty easy, okay? X minus 10 equals 0. We know that the... I was about to say, come on. It's being really, really slow all of a sudden. Alright, let's try this one again. Hopefully we ain't got no more hiccups here. Alright, so we know to add 10 to both sides. Okay, minus 10 plus 10 gives me 0, gives me x equals 10. So x equals 10. Okay, because 10 minus 10 is 0. It's the only solution that works. Alright, x divided by 2 plus 20. This is the same as saying 1/2 of x plus 20 equals 0. Okay, so we add 20, we subtract 20 from both sides. Okay, we get left with 1/2 of x. 20 minus 20 is 0, so that equals 0 minus 20 is a negative 20. We multiply by the reciprocal of 1/2, which is 2 over 1. So multiply by 2. 2 over 1 times 1/2 gives me 1, leaves me x equals negative 20 times 2 is a negative 40. That is my solution. Okay. Now, I went through all that for the easy crap, okay? Now, here's what I need you to understand, okay? Demanding Dwight insists that you give him two solutions to the following equation, x minus 10 times x divided by 2 plus 20 equals 0. Can you provide him with two solutions? If you look at the factored expressions, x minus 10 is the same as a. X divided by 2 plus 20 is the same as b. The idea is that one of these factors has to be 0. Okay? Doesn't matter what the other value is. If one of them is 0, remember, 0 times anything is 0. So in this situation, we're trying to find what solutions would make one of these factors 0. Okay? So think about it. What number could I subtract from 10 to get 0? All right, I can get 10. So x can equal 10. Is that the only thing that x can equal? What number can I put here, x divided by 2 plus 20, that'll make this factor equal 0? Right, negative 40. So x can equal a 10 or a negative 40. But is there a faster way that I can do this? There is. Okay. So when you're working with a factored expressions like this, and they're both set, and it's set to equal to 0, okay, what you can do is you can actually break up the factors and set them equal to 0. X minus 10 equals 0, and x divided by 2 plus 20 equals 0. If you set each individual factor to 0, you can come up with the solution. Okay? Easy peasy. All right? Now, let's look at D. Demanding Dwight now wants 5 solutions to the following equation. Can you provide him with 5 solutions? Do you think there might be a 6th solution? Okay, well, let's look. We already see an x minus 10, and we already see the x divided by 2 plus 20. We already know the solutions to those. We know that x can equal 10, and x can equal a negative 40. So let's look at 2x plus 6, x squared minus 36, and x plus 10. Let's set those equal to 0. 2x plus 6 equaling 0. X squared minus 36 equals 0. All right, and x squared plus 10 equals 0. Okay. We subtract 6 from both sides. We get 2x. 6 minus 6 is 0 equals a negative 6. Divide by 2, divide by 2. 2 divided by 2 is 1, gives me x equals a negative 3. Well, there's another solution, negative 3. X squared minus 36 equals 0. We add 36 to both sides. 36 minus 36 is 0, gives me x squared equals 36. The square root of x squared equals the square root of 36. Square root of x squared is x equals... Now remember, when you do the square root of a positive number, both the solutions of positive and negative, square root of 36, which would be 6, are solutions. So x can equal positive or negative 6. Well, there's 5 solutions right there. Okay, so those are 5 possible solutions. So do we need to do x squared plus 10? Yes, we still need to do x squared plus 10. Subtract 10 from both sides. Okay, 10 minus 10 is 0. 0 minus 10 is a negative 10. X squared equals a negative 10. The square root of both sides, okay, x equals the square root of a negative 10, and that is actually not true. There is no number that we can square to get a negative 10. So there is no way we can get a solution that will give me a 0 in this. No solution whatsoever. Okay? Doesn't work. It's not possible. X cannot equal the square root of a negative 10. Does not work. Okay? Yes, I know it looks perfect, but there is no way x can equal this negative square root of 10. All right? So do you think there might be a 6th solution? No, there is not. Okay? There is not a 6th solution to this expression. There is not another solution. These are the only 5 solutions. X equaling 10, x equaling a negative 40, a negative 3, and a positive negative 6. Do not fall for this trap right here, okay? That is not going to be a possible solution. Do not fall for that crap. Do not fall for that messiness. You are better than that. Do not fall for that kind of a solution. Okay? All right, continuing on. Now, consider the equation x minus 4 times x plus 3 equals 0. Rewrite the equation as a compound statement. Okay? Compound statements use the words and or. Okay? So, in this case here, x minus 4 equals 0 and x plus 3 equals 0. Okay? That is a compound statement. We're stating that these two factored expressions can equal 0. Okay? So find the two solutions for the equation. Well, what value of x would make minus 4 equaling 0? Right. X would have to equal 4. And x would have to equal what? Right. Negative 3. Okay? Now, example number 1 is one of my favorite problems. Okay? Because you look at this and you're like, what in God's green earth, Mr. Hale? Okay. If you remember, we talked about, a long time ago, we talked about greatest common factor. Okay? If I asked you what the greatest common factor of 10 and 25 was, you would tell me that the GCF would be 5. Because that's the only number that I can pull out from both 10 and 25. Because if you remember, the factors of 10 are going to be 1 and 10, 2 and 5. Whereas 25, you have 1 and 25, and you have 5 and 5. 5 is the greatest common factor. I can pull out a 5. Okay, because think about it. This 10 now becomes 5 times 2. This 25 now becomes 5 times 5. If I pull out a 5, then I can reduce the factors. It's just no different than a factor tree. Okay? So look at 2x squared minus 10x. What's the greatest common factor that I can pull out from this? Well, let's start off with the numbers. The 2 and the 10. What's the greatest common factor of 2 and 10? A 2. Okay? What about x squared and x? Can I pull out greatest common factors there? Well, think about it. X squared and x. Okay? If I was going to write down the factors of x squared and x, I'd get x and x, and then I'd get 1 and x. What's the greatest common factor between the two? It would be an x. So I can pull out an x. Okay? Well, what number, or what can I multiply by 2x to get 2x squared? X. Minus, what number did I multiply by 2 to get 10? 5. What number did I multiply by x to get x? 1. So now I'm done. 2x times x minus 5 equals 0. Okay. I expect you to ask questions because that right there, I know I lost about at least 50% of you. Out of 31 kids, I'm pretty sure that I've lost to 10 to 15 of you. Okay. I want you to ask questions about this on Thursday. All right, so now we got ourselves an equation that we can write a compound sentence for. Okay, 2x and, or sorry, not 2x. 2x equals 0 and x minus 5 equals 0. Okay, divide by 2, we get x equals 0. Add 5, we get x equals 5. So x equals 0 and x equals 5. Those are our solutions. Those are the only two solutions that would work. Okay? All right. All right. I'm going to save this one for classwork because this is going to require a major explanation. Okay? So that's going to be our classwork. So no rush, no hurry. Okay? All right. Now, at this point here, we should know by now, okay, what I'm doing. So if I'm hoping that you paid attention, so I'm going to run through these pretty quick, okay? X plus 1 times x plus 2 equals 0, all right? So x plus 1 equals 0, and x plus 2 equals 0, okay? We subtract 1 from both sides, we get x equals a negative 1. And then we subtract 2 from both sides, we get x equals a negative 2. So my solutions are x equals a negative 1 and x equals a negative 2. Okay? Easy peasy. All right. 3x minus 2 equals 0 and x plus 12 equals 0. All right, we add 2 to both sides. We get 3x equals 2. Divide by 3 on each side, we get x equals 2/3. And we subtract 12 from both sides. We get x equals a negative 12. So x equals 2/3 and x equals a negative 12. Again, my solutions. All right, so now, this is what you call us. This is a product of squares. Well, not a product of squares, but I love these kind of problems. All right, so x minus 3 equals 0 and x minus 3 equals 0. Add 3 to both sides, we get x equals 3. Add 3 to both sides, you get x equals 3. So the solution is x equals 3. The only solution, x equals 3. Okay? All right. You're in class today, so what I want you to do for your... Okay. So, Alexa, what is tomorrow?
Tomorrow will be Wednesday, October 21st, 2020.
All right, so for 10/21, your classwork, I want you to do 5, 6, and 7. Oh, not 7. Not 7. I don't want you to do 7. This is going to be classwork for 10/22, okay? All right, so let's look at example 3. Consider the equation x minus 2 times 2x plus 2x minus 3 equals x minus 2 times x plus 5. Lulu chooses to multiply through by 1 over x minus 2 and gets the answer x equals 8. But Poindexter points out that x equals 2 is also an answer, which Lulu missed. All right. Yeah, this is going to be a this is going to be a 10/22 classwork problem. Okay. All right. Let's see. And number 8 is going to be a 10/22 classwork problem as well. I do not want to overwhelm you with videos on this, okay? Sorry, I'm taking a look at something, guys. All right, I want you to do A and B as 10/21 classwork, okay? C is going to be 10/22 classwork. All right. Okay. Let's do numbers 10 and 11. We want us to verify something, okay? So Okay, so we're verifying that a minus 5 times a plus 5 gives us a squared minus 25, and x minus 88 plus times x plus 88 equals x squared minus 88 squared. Okay, so we're going to verify that. Now, if you remember, I told you about FOIL. Okay, F represents the first terms, O represents the outer terms, I represents the inner terms, and L represents the last terms. Okay, so the first terms, A times A. Well, A times A is A squared. Okay, the outer terms, okay, A times a positive 5A gives me 5A. The inner terms, a negative 5 times A gives me a negative 5A. And then the last terms, negative 5 times a positive 5, which gives me a negative 25. Well, 5A minus 5A is going to reduce to 0, leaving me A squared minus 25 equals A squared minus 25. This checks. It's correct. Okay. This is what you call a difference of squares. Okay. This is known as a difference of squares. What do you mean, Mr. Hale? Well, a squared is a squared, and 25 is the same as saying 5 squared. This is what you call difference of squares. Okay? So let's verify this one here. Okay? Same thing, first, outer, inner, last. So first, x times x, okay, is going to be x squared. The outer terms, x times 88 is going to be a positive 88x. The inner terms, negative 88 times x, gives me a negative 88x. And then the last terms, 88 times the positive 88 is going to give me a positive 88 squared. Yes, I'm doing what... Oh, sorry, not a positive 88 squared. My bad. That should be a negative 88 squared. Negative 88 squared. All right, 88x minus 88x is going to reduce to 0. Gives me x squared minus 88 squared equals x squared minus 88 squared. This checks, so it's good. Okay? Again, a difference of squares. If you have the same terms, but the only difference is the addition and the subtraction, multiply the first two terms together, multiply the last two terms together, and that'll be your answer. You don't have to worry about the stuff in the middle. All right? Again, if you have questions, ask your questions when we get there, all right? All right, so verify a squared minus b squared equals a minus b times a plus b. Ah. Really? Don't you just love it when it goes backwards on you? We're not going to verify that. There's no point. And I'm not going to sit there and try to make you do it either. All right, so we're not going to do C. Okay. I'm going to let you do E for classwork, 1021 classwork. I'm going to do D, okay? So we got x squared minus 9 equals, now we're going to use the distributive property here, 5 times x, 5 times a negative 3. 5 times x is 5x, 5 times a negative 3 is a negative 15. Okay. Now the goal is that I want all this to equal 0 because I want to know the solutions. I want to know what the value of x is. So my goal is to get everything from one side to the other, okay? So I'm going to subtract 5x from both sides. Okay. Now I've got x squared minus 5x minus 9 equals a negative 15. Now I'm going to add 15 to both sides. Add 15 to both sides. Okay. Now I've got x squared minus 5x plus 6 equals 0. Okay. Oops, forgot that right there. All right, so this is interesting why they throw this lesson out at you, because this is not what you expect it to be. So I'm not sure why they're throwing these questions out at you like this, but this is a factor equation, okay? This is something that we have to factor. And I know you're sitting here like, what do you mean we have to factor, Mr. Hale? So when you've got a trinomial, the goal is that you want to factor it back into two binomials. okay? Because we're not going to use the quadratic formula to find out the solutions. That's mumpkus. All right, we're going to use the we're going to factor in the terms of binomials. Okay. Now, here's the thing, okay? We want to know the factors of 6. Listen to me. The factors of 6 that will give me a sum of a negative 5. Okay? So let's work with the factors of 6 first, okay? What are the factors of 6? Okay? 1 and 6, 2 and 3. Okay? Now I want a negative 5. Okay? So I need these to add up to a negative 5. So the sum of these has to equal a negative 5. So if I was to add these numbers, they have to equal a negative 5. Okay? Now that means I could do any combination of positive and negatives. Okay, well, 1 plus a negative 6 gives me a negative 5. That's true. But does 1 times a negative 6 give you a positive 6? Does not. Okay. What about a negative 2 plus a negative 3? Negative 2 plus a negative 3 does give me a negative 5. Okay. And a... I'm sorry, guys. I'm sitting here and I'm thinking to myself, this is just not fair to you. Because everything I'm about to have to explain to you, we have not gone over. I swear. I'm sorry, guys. Ask me questions on Thursday. I will do my best to explain all this to you, but I'm just going to run through it again, okay? So negative 2 plus a negative 3 is a negative 5. Negative 2 times a negative 3 gives me a positive 6. So what you do is you take the x squared, and then you take the negative 5x, and you break them into these two factors with the variable x at the end of it. So a negative 2x plus a negative 3x, okay, plus 6. Now you group these factors together, okay? And then what we have to do is now that you've grouped these binomials together, now we got to sit here and factor certain things out. Like here, I can factor out an x. I get x minus 2, okay? And then I'm going to factor out a negative 3 here, and I get x minus 2. So now my factors are x minus 3 times x minus 2 equals 0. Now I can set my factors, and now I can set my factors to 0, giving me x minus 3 equals 0 and x minus 2 equals 0. Sorry, x minus 2 equals 0. Solutions are a negative 3 and a negative 2. So x equals a negative 3 and x equals a negative 2 are the solutions. Yeah, we're going to save this one till the 22nd. Okay? I'm sorry, guys. I don't know why in the world this problem got tossed in here this way. And I know you're looking at me like, Mr. Hale, how in God's green earth do you know how to solve that problem like that? This comes from years of practice, guys. This is just procedural memory right here. Okay, I know the steps on how to do it. So we're going to stop right there for right now. We're going to do 11 for 1022 classwork, okay? What I want you to work on tonight, or in class, I'm sorry. In class, I want you to do, I want you to find the solutions for A, B, A, B, 2, and 6, okay? That's what I want y'all to do tonight. Not tonight for homework. This is your classwork. You're not going to have any homework from me. Try to get through this to in class. Finish watching the video. Man, I'm sorry, guys. I know that last problem was not what you were expecting. I am so sorry. I know there's a lull in silence right now. I'm gonna try to. I've got a couple whiteboards here at my house. I think I'm gonna try to get them up tomorrow, or Thursday. And as part of one of your videos, I'm gonna go through on how to factor, how to turn a trinomial into a binomial, and actually walk you through the proper steps. Because that's gonna be something handy that you guys are going to need. Uh, so, like I said, I'm so sorry. I did not expect that problem to turn out that way, and it's on me. But if you're able to understand it, fantastic. If you're not able to understand it, it's not the end of the world. We'll get through this together, and we'll work out some problems, and we'll hopefully get some practice on it, okay? So I want you all to have a good day tomorrow. Focus on this, on the video. On Thursday, you are going to have a small CFA assessment from me to start the day off, but then we'll dive right into this, so just be prepared for that, okay? You guys have a wonderful day, and enjoy your Wednesday. Remember, it's Hump Day. It's the middle of the week. You made it through the middle of the week on the week after fall break. The fall break that has already ended, and now we're on our way to Thanksgiving. No Thanksgiving, no Thanksgiving. Yes, 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 yes. We're only about 5 weeks away from Thanksgiving, which you get another full week off, in Thanksgiving, and then it's just another couple weeks, and then you get 2 weeks off for Christmas, Christmas, Christmas. Oh my God! Yes, it's almost there. All right, I'm sorry, guys. Like I said, y'all have yourselves a good one, and I appreciate you guys listening up and doing your best to follow along. All right.